Hello everyone, today we're looking at alkene reactions and we're looking at reaction number 1 to number 8. So number 1 to number 8, and this is presented to you by Science Visualized. If you look at reaction number 1, we are using Br2 and that adds Br and Br across the double bond. So if the reagent is Br2, you end up adding Br and Br across the double bond, and that addition is anti. So you end up with one Br going out and the other one in. Or the other, or opposite. You could have this one going in and that one going out. Number 2, with chlorine, you're going to add Cl and Cl anti, just like Br, only that now you're going to replace that with chlorine. Now, number 4, using mercuric acetate, water, and sodium borohydride, the end result is that you end up with hydration, addition of water, which is basically H and OH across the double bond, and that adds Markovnikov. Markovnikov means this hydrogen adds to the carbon with the most hydrogen. So if you look at these carbons, B and C, the alkene carbons, B has one hydrogen, C has no hydrogen. So B has the most hydrogen, and therefore H adds to that. And then OH adds to the carbon with the least hydrogen, which is C, and therefore you end up with the OH there. So you add H and OH across the double bond. Number 5, we are using borane like BH3 or B2H6, sodium hydroxide, hydrogen peroxide, and water. The end result is also hydration, where you add H and OH, but now anti-Markovnikov. So opposite what we saw before. Now H adds to the carbon with the least hydrogen, so you end up with H there, and then OH to the other carbon. Number 6, reaction with water and any acid. So the acid could be HCl, H3, PO4, different types of acids, HBr. So water with acid, or if you combine them together, it forms hydronium ion. So hydronium ion is H3O+. So that's basically water and H+. You end up also carrying out hydration, and that's Markovnikov, just similar to what we saw with the mercury. So you end up with H added to the carbon with the most hydrogen, and then OH to the carbon with the least hydrogen. Number 7, here we have X2, where X2 is halogen, so it could be Br2 or Cl2, just like what we saw here, but now with water. So what happens is that you end up adding X and OH across the double bond, and that's called halohydrin. The product will be called halohydrin. So you end up adding X to the carbon with the least hydrogen, and then OH to the other carbon. Remember, anything that involves X2, Cl2, Br2 adds anti. That means one group goes in, the other one goes out. Number 8, Br2 and water. So that's a specific example of number 7. Now instead of X2, we are using Br2. So you end up adding Br and OH across the double bond, where Br adds to the carbon with the most hydrogen. So Br and then OH to the other carbon. And you can extend this reaction and use, say, Br2 with alcohol. In that case, you end up adding Br to that position. But now instead of OH, you're going to add the alkoxy group. That group there will add. So you end up with that as the product. Thank you very much for listening. If you enjoyed this presentation, please like this video and also support the channel by subscribing. Stay tuned for the other remaining parts.